And that I'm really excited to have here. They're going to connect some of the stuff you're learning to what it means in their world. So we have Wes King, who's an architect with NMR, and John Corless, who's the engineer with NMR as well. So these gentlemen are going to have some things to say, and then they have some time for Q&A as well. So kind of keep that in mind. So if you end up with a question, as you're thinking about it, jot it down, because they're going to answer questions. All right? Gentlemen, thank you.
Thank you. This is kind of fun. I've done a career day at Sequoia not too long ago, and I did my son's second grade class years ago. So this is good to be working up to the teachers. I love math and science in school, and throughout my career I've worked on a lot of school projects, starting with the Toledo High School, one of the first projects I worked on, and now my oldest children are going there. So Chris asked us to talk about important elements that we consider from an engineering perspective in earthquake engineering of buildings. And some of the things we look at when we're determining how the building is going to resist earthquakes, we have to look at the location, the seismicity of the specific location, which I'll go into here, and the soil type. The softer soil, buildings will move more. If you study the Mexico City earthquake, I think it was 1985, had tall buildings that were the right period for the loose. It's built on an old lake there, an infilled lake. So had these 20-story buildings tipping over, where normally those are pretty safe if they're on stiff soil. So the soil, also the type of the building, whether it's a commercial building or a residence or a hospital, we design to be for higher load so they can be fully functional after an earthquake. And a school's in between there, a large school, we want it to be a safer, someplace could be a shelter. So with that, I'll jump right into this, show you how we come up with the forces for designing. And then I brought a few props here. There we go. So to get the seismicity of the site, used to be we'd go to a map in the building code, but now, hopefully this link will work. Now we go to this USGS website, and we'll plug in some information about the site, and then we can look up the seismicity of it. So first thing we check is the building code, which we're under the 2013 California Building Code, which is based off the IBC, or International Building Code, that's used throughout the country. And then we'll check the soil type, which the default is stiff soil, where this mouse is touchy. So we'll go with that. And then risk category, category 4 is an essential facility like a police station, fire station, or hospital. We'll go with 1, 2, 3. And then in here, you can plug in the address, so if this will work. We'll plug in where we're at here. See if that'll come up. Sure enough. So this is kind of a fun application.